Hello, viewers all over the world. I remain your humble mathematician, Godwin Honor, otherwise known as GONS, Godwin Honor Mathematics Solution. Okay, so let's consider the next episode, which is episode 17. Episode 17. So what does the question say? It says find dy dx by implicit differentiation of x squared y squared minus 3xy plus 4xy index 3 equals to 4. Say find dy dx. That's a change in y with respect to s by implicit differentiation of what? X squared y squared minus 3xy plus 4xy index 3 equals to 4. Okay, as usual, analysis and solution. So this kind of question is implicit differentiation. So under differentiation is called implicit differentiation under calculus. Okay, so we are expected to look for dy dx. We are asked to find dy dx. How do you find dy dx of this kind of problem? So before we start, let me first of all show you one or two examples. Yes. Okay, in case you have, let's say A, y equals to f of s, then y equals to s maybe k minus 2s squared plus what? Maybe 4. Then B, we have what? F of s comma y equal to 0. Then here I have s, that's 3y plus what? Let's say s 3s y square equals 0. Okay, looking at these two examples, the first one is that is a and y equals to f of s, where y equals to what? S index 3 minus 2s squared plus 4. This is an example of what? Explicit differentiation. This is explicit. Here y is dependent on x. Y is a dependent variable here, ys is independent. So the value of y depends on the value of x. That as for the first example, that is A. You discover that whatever you get for your y depends on the value of s. But for B, it's not like that. This is f of s comma y, f of s comma y, close bracket and equals to 0. So you discover that s and y are involved here in the question. So here, y is more involved here and s. Not like maybe y is a dependent and s is independent here, but both of them, they involve in the question. So this is an example of an implicit differentiation. And if you look at the question on the board, you discover that this is a question from here. So it's an implicit differentiation. Okay, so when we are dealing with an implicit differentiation, so we solve implicit problem using what we call a product rule. So in differentiation, we have different rules of solving a differentiation. We can solve differentiation through what? First principle, through what? Sum or difference of a what? A function, through product rule, quotient rule, and others. But as for this implicit differentiation, so we use product rule. Why are we using product rule? Because you can see this is a s square y square. So they are together here, they are together here, they are together here. sy cube. So since the two functions or the two factors are together, you use a product rule. Okay, so let me clean here. So that's just it. So how do we do this? Then we first of all by saying what? Let me just say part one. So we have to state the formula for what product rule. And you say that y equals to u v equals to what? U dv over ds plus v du ds equals to what? U dv plus 1v du. Okay? So this is the product what? A format or formula. Y equal to uv. U stand for the first factor, which is s squared here. The v stand for the second one, which is y squared. So the same thing here. You see? So what we are saying here is that you should hold down the first one, you differentiate the second. Plus, you hold down the second one, then you differentiate the first. That is what you see. So this is the summary of what is here. So this is the formula for what? For differentiation by products. This is the formula. So let's start. Having seen this now, so let's start. Okay, let's start. Now what we are to do now, we have to what? Differentiate this one by product. Differentiate by product, differentiate by product. How do you do that? It's which implies you first of all start like this. Then it means that the s squared, then dds, open bracket, okay, plus we are treating this. Then what we are saying is that hold down this, differentiate this. Plus you hold down this, you differentiate it. So you now say then dds of what s index. Okay, so I'm done with this. Then minus, you come to this one. So you open again, which is 3s, then dds of what 1 plus, you hold down this now, the y dds of what 3s. Okay, I'm done with this. Plus, open. This is a 4s and dds of 1 minus 3. Then plus, you know, 1 index 3, what? Then dds of 4s, then equals dds of what? Of the constant. Okay, so what I have just done here now is that where based on the formula I have stated, I've hold down what s squared, then you are now saying that you should differentiate what? Y raised to the power of 2. And anytime you differentiate y, you must attach dy ds anytime you differentiate y. But if you differentiate s, you will not attach dy ds. So here now plus, then you hold down dy, that is a y index 2, dy ds, you know, that is a dds of s squared. You close it, you are done with this, minus open bracket and close. So here now is a 3s, you hold down 3s, then dds of y plus, you hold down y, then you have a dds of 3s. You are done with this, then plus, you hold down 4s, dds of what? Y index 3 plus, you hold down y index 3, the dds of our 4s. They are equal to dds of constant. So that is just it. Then let's go again, which implies. So we have to differentiate now. Differentiation of this now, and I have told us differentiation is a method in which you use the power to multiply with the factor or the function, then you deduct 1 from the power. Okay, so that is it. So for us to differentiate this, we now have something like a 2s, 2s, okay, 2s squared y, then dy ds, because we are differentiating what? We are differentiating y plus Then let's see it. To differentiate this one, I will have a what? 2s. That is a 2s, then y squared. Okay, you discover that as I differentiate what? S squared. So that is a 2 times x. Then 1 minus from 2, you have 1. S raised to the power of 1, which is a 2s. Then you use it to multiply with what is here. You have about 2sy. You discover that I did not apply dy dx, just like as I did here. Why I applied dy dx here? Because I differentiated y here. Here I differentiated s. Then minus, then coming to this side. Differentiation of this one will just give you 1. 1 times this will give you minus 3s, then dy ds. You know I differentiated y. Then minus, because minus plus will give you minus. Differentiation of this one will give you 3. So 3 times y will give you 3y. Then nothing like, do you see I did not apply dy because it's a 3s. Then plus, then differentiation of this one, this is a 3 times this, it will give me 12. Then 3 minus 1 will give you 12. So it will give us 12s, yes, y, index what? Index 2. Then dy ds. Do you understand? Plus, coming to this side, then differentiation of this one will give us what? 4. Y index 3. You understand? Index equals to, because differentiation of 4s will give you 4. 4 times y index 3 will give you y. 4y index 3. Then equals to what? 0. Differentiation of constant is always 0. Differentiation of constant is always 0. So this is it. Understood? Yes, this is it. Okay, then with this, let me clean it. You've seen where we reach here, so let me clean up the first one so that I will continue. Okay. Okay. So let me give this one as a part 2 so that they work with it. So part 2 now. So you should be able to understand where we start at part 1 and where we stop with part 1. This is part 2, but we will continue. So here now, look up. You see that this is dy, this is dy, this is a dy. So we collect items, we bring them together. And this, we take them to the what? To the right-hand side. So here is, which implies, this is, so I can put it like this, 2s y. I've chosen this one, minus 3s, which is this one, plus 4sy squared. Then I will not put a dy ds because they are common, you can see. So I factor out our dy ds equals, without waste of time, you know, all of them, they are on the left-hand side. So I have to move this one to the right-hand side. I will move this one to the right-hand side, and I will move this one to the right-hand side. So by moving them to the right-hand side, their sense or their sign will change. This one is plus, this one is minus, this one is plus. If I move them, so I will choose the one that we first of all will change to positive, which is this one. So I will first of all write it, which is 3y. You see, because when it crosses this equality sign, it changes to plus. You understand? Then I will not choose this one, minus 2sy squared. Then the last one, which is this, minus 4. So, okay, so what I have just done here, this is a 2sy, there's 2. I move it to the right-hand side. The sign will change. Okay, I first of all move this minus 3y. When this minus 3y, if you cross this equality sign, it will change to what? Plus, and that is why you see it here. Then I move this one, it changed to negative. Then I move this plus 4 y index 3, it changed to negative because it's plus here. So that is it. Okay. So what are we looking for? We are looking for dy ds. Therefore, dy ds. So what are you doing now? The last thing that you do, you now divide both sides by the coefficient of dy ds. What is the coefficient? You can see it. 2s squared y minus 3s plus 12s y index 2 is the coefficient of dy ds. So you are using it to divide itself and the right hand side. So which give us 3y minus 2sy squared and 4 equals, so this is 2s squared y minus 3s and plus what? 12s y. Okay, so I think this is the answer to this question. So automatically your dy ds is a 3y minus 2s y index 2 minus what? 4y index 3 all over 2s square y minus 3s plus 12s y index 2. And that is the answer to this very question. So viewers all over the world, this is answer to this. Thank you.